Hey guys, Dr. Brown here with Kubo Math, and for this video is for all you partial fraction freaks out there. We have another problem dealing with the integral of 3x squared minus 4x minus 1 divided by x squared minus x minus 2. Now I'm going to show you the wrong way to work this and what the answer you'll end up with. And then we'll go through the correct way to do this. Okay, so immediately you may think, hey, I'll just factor that denominator, which is what partial fractions, that's one of the steps. So if we factor this, we end up with x minus 2 and x plus 1. So immediately we may jump in and say, well, hey, that's the integral of a over x minus 2 plus b over x plus 1 dx. We solve for a and b. We end up with a equals 1, b equals negative 2. Some simple integrals now. So we end up with the integral of 1 over x minus 2 minus the integral of 2 over x plus 1, which is natural log of x minus 2 plus, or minus 2 natural log x plus 1. Now, obviously to check ourselves, we'll set up a derivative here and we'll take the derivative of the answer and we should end up with this function we started with. And you can immediately look at this and think, I don't think I'm going to end up with all of that. So we set up the derivative. We take the derivative of natural log of x minus 2, which is you're taking the derivative of the integral of the derivative of the function over the function. What's the derivative of x minus 2? It's just 1. So I have 1 over x minus 2. The integral sign drops off with the derivative. Minus 2 over x plus 1. And then I go through and I get a common denominator, and I end up with minus x plus 5 over x squared minus x minus 2. That is not what I started with. There's a rule we forgot to implement. When you're looking at linear non-repeated factors, which is what I have here, linear non-repeated, okay, I need to make certain that the numerator, its power is less than the denominator. In general, it's the smart thing to do anyway. If you can reduce this by performing long division, you should default to do that. Because in this case, if you don't perform the long division, you absolutely will get the wrong answer. So make a mental note of that. Let's default to performing long division and ensure that the numerator is of a lesser power than the denominator. Okay, so if we go through that division, we have 3x squared minus 4x minus 1 divided by x squared minus x minus 2. Now I end up with 3 plus minus x plus 5 over x squared minus x minus 2. Now I can factor this, and of course the integral of 3 dx plus the integral of this with the denominator factored in with the same factors I had earlier. Okay, so I go through that same function again, and by the way, when I solve for a and b, they're still, a is 1, b is negative 2, same as before. And I end up then, when I go through the integral, 3x plus natural log x minus 2 natural log x plus 1. Now you'll notice that this piece is what I had over here. I just didn't have the 3x. So I had a portion of this thing, but not all of it. Now then, if I take the derivative of this function and I go through and I get a common denominator, slowly walk through that, I do in fact end up with 3x squared minus 4x minus 1 over x squared minus x minus 2. Okay, this is not a very long video. I just wanted to point out the fact that if you have a polynomial divided by a polynomial, and that's an opportunity then to perform partial fractions, ensure that you perform long division to get the numerator to a lesser power than the denominator, and then go through the process of the partial fractions. Okay, why are we doing this? Hey, together we're trying to build a better tomorrow and do that through math. Keep studying, guys, and certainly implement this rule in your day-to-day activities of your math and calculus. All right, that's all for now. Talk to you next time. Thanks.